In Module 3, Lesson 14, we're going to practice solving more inequalities. The annual county carnival is being held this summer and will last 5½ days. We're going to use that information and the other given information to answer each problem that follows. You're the owner of the biggest and newest roller coaster called the Gentle Giant. The roller coaster costs $6 to ride. The operator of the ride must pay $200 per day for the ride rental and $65 per day for a safety inspection. If you want to make a profit of at least $1,000 each day, what is the minimum number of people that must ride the roller coaster to make that profit? So we are looking at the number of people, and that's what we're going to represent that with P, that must ride the roller coaster each day, and the charge for each person is $6 per ride. So 6P will need to be greater than or equal to, no, greater than, because we need to make a profit. It's going to need to be greater than $200 per day for the ride rental, plus $65 per day for the safety inspection, and you want to make a profit of at least $1,000. So yes, we would need to go back and change this to greater than or equal to, because 1,000 is included in that possibility. At least means you could make just a profit of 1,000 or more. Next, we'll solve the inequality, and we'll start by combining like terms. Which are our numbers. And 6B will need to be greater than or equal to 1,265. And then we divide by 6. And find our answer to be 210. And a repeating decimal, 8, 3, and the 3 repeats. Now that's the solution of the inequality. P needs to be greater than or equal to 210 and 83 hundredths repeating. But we do need to interpret that solution because we should be completely aware that there's no possibility of 0.83 people riding. So obviously we would need to round up, because if we rounded down, that wouldn't be enough. That means they need at least 211 people to ride every day. In order to make the profit. So example 1, the youth summer camp has budgeted $2,000 for the campers to attend the carnival. The cost for each camper is $17.95, which includes the general admission to the carnival and 2 meals. The youth summer camp must also pay $250 for the chaperones to attend the carnival and $350 for transportation to and from the carnival. So we're asking, what is the greatest amount of campers that can attend the carnival if the camp must stay within their budgeted amount? Well, first of all, we have $17.95 C per camper. That's the cost per camper. And then there's another $250 that has to be paid for chaperones and another $350 for transportation. And their budget is $2,000. So they must stay less than or equal to $2,000. So our inequality then, 1795 times C plus 250 plus 350 needs to be less than or equal to 2,000. We'll combine our like terms. 1795C plus 600 needs to be less than or equal to 2,000. And then we'll solve. Subtracting 600 means it will need to be less than or equal to 1,400. And then finally dividing by 1795. And our answer is a non-terminating decimal, which if we round to the nearest penny is $77.99. 77 and 99 hundredths of a camper. And that's not possible to have 99 hundredths of a camper, so we would need to have a minimum of, or a maximum, we would not quite have enough if we rounded up to 78. So we would need to have the maximum number of campers will be 77, since we won't have enough for 78. Example 2, the carnival owner pays the owner of an exotic animal exhibit $650 for the entire time the exhibit is displayed, and the owner of the exhibit has no other expenses except for a daily insurance cost. If the owner of the animal exhibit wants to make more than $500 in profits for the 5 1/2 days, what is the greatest daily insurance rate he can afford to pay? So we've got 5 1/2 days. I'm going to make that a decimal. It'll be easier for me to work with right now. 5 1/2 times D, the number of days. And he wants to make at least 500 in profits. So he wants the amount of his insurance rate plus at least 500 to be greater than, no. So what we're looking at is 650, the entire amount that he's being paid, minus 5 1/2 times the number of days, which is the cost of the insurance rate, needs to be greater than 500, which is what our exotic animal owner wants to make. Again, the entire amount that he's being paid minus the insurance rate, which is 5 1/2 times the number of days, needs to be greater than 500 so he can have more than $500 in profits. Now, that being the case, to solve this, we're going to start off, we would have negative 5 1/2 times D will be greater than 500 minus 650, which is negative 150. And while those negatives may be rather confusing, remember that now we're going to divide by negative 5.5. That's going to give us D. If we think back to our previous lesson, we went through the stations and we did those tables. We discovered that if you divide by or multiply by a negative number, your symbol has to reverse. So we're going to change that to less than, and then negative 150 divided by 5.5 will give us $27.27, which is rounded because the decimal does repeat. So the greatest amount that he can afford to pay is $27.27. And finally, example 3. There are several vendors at the carnival who sell products and also advertise their businesses. Shane works a recreational company that sells ATVs, dirt bikes, snowmobiles, and motorcycles. His boss paid him $500 for working all of the days at the carnival, plus 5% commission on all of the sales made at the carnival. The minimum amount, they want to know what the minimum amount of sales Shane needs to sell if he earned more than $1,500 during that time. So he's going to earn 500 plus 5% commission, which is 5/100ths of the sales. And so that's 5/100ths times S. And we know that he earned more than $1,500, so it is greater than 1,500. To solve, we would subtract 500, and that'll give us 5/100ths times S is greater than 1,000. And then we'll need to multiply by the reciprocal, which means we're multiplying by 100 over 5. And we find that his sales had to have been greater than $20,000. So to review, the goal to solving inequalities is to use if-then moves to make zeros and ones to get the inequality into the form x is greater than a number, or x is less than a number. And adding or subtracting opposites will make zeros. Multiplying and dividing numbers make ones, which is good. A positive number that's multiplied or divided to each side of the inequality does not change the solution of the inequality. However, multiplying or dividing each side of an inequality by a negative number does reverse the inequality sign. So that's the only difference in our solving, is that when we multiply or divide each side of an inequality by a negative number, we will have to reverse the inequality sign.